Quantum technology.
What on earth is a quantum computer?
It's qubits. Try all the codes at once.
Whichever nation first develops a practical quantum computer will have a tremendous advantage.
Quantum supremacy.
Imagine a world where unsolvable problems are solved in seconds, where complex calculations that would take a supercomputer years to compute are done in a blink of an eye. Welcome to the future, a future powered by quantum computing and artificial intelligence. This is not just a technological revolution. It's a quantum leap into a new era of human innovation. Here is everything you need to know about quantum computing and AI. What is quantum computing? In simple terms, quantum computing is an area of computer science focused on the development of technologies based on the principles of quantum theory. Quantum computing uses the unique behaviors of quantum physics to solve problems that are too complex for classical computing. Let's play a game. I want you to imagine a coin. In the classical world, this coin can either be heads or tails. But what if I told you there's a universe where this coin could be both heads and tails at the same time? Welcome to the world of quantum computing. In this realm, our coin is a qubit, the fundamental unit of quantum information. Unlike the bit in classical computing, which can be a 0 or a 1, a qubit can exist in a state that is a superposition of both, thanks to a quantum quirk called superposition. It's like Schrodinger's cat, both alive and dead until observed. Now, imagine 100 coins, or qubits, each representing multiple states at once. The number of possibilities grows exponentially, not linearly, like in classical computing. That's the raw, mind-boggling power of quantum computing. But you might be thinking, that's great in theory, but how does it translate to the real world? Well, consider this. Today's encryption systems, the ones that secure your online transactions, are based on complex mathematical problems that even the fastest supercomputers can't crack in a reasonable time. But a sufficiently powerful quantum computer could. Scary, isn't it? We're not just talking about faster computers. We're talking about a paradigm shift in computational power that could unlock answers to questions we haven't even thought of asking. Quantum computing versus classical computing. Picture yourself in a grand music hall. On stage, a lone pianist plays a captivating melody on a traditional piano, each note resonating beautifully. That pianist represents classical computing, where each key pressed can only produce one note at a time. But what if I told you there's an instrument that could play multiple notes simultaneously with just one key? Enter the world of quantum computing. In this analogy, the quantum computer is like a futuristic piano with keys that play not just one, but several notes at the same time. It harnesses the peculiar properties of quantum mechanics, like superposition and entanglement, to process information in ways that classical computers simply cannot. But what does that mean for us in practical terms? Consider a maze. The classical computer would methodically explore each path one at a time, taking ages to find the exit. A quantum computer, on the other hand, could explore all paths simultaneously, reaching the exit in a fraction of the time. This ability to perform parallel computations gives quantum computers an edge over their classical counterparts in solving complex problems. What can a quantum computer really do? Imagine you are a painter, but instead of having only 3 primary colors to mix and create your palette, you have a million. The array of colors you could create would be nearly infinite, right? That, in essence, is what a quantum computer brings to the world of computing. An ability to process an enormous amount of information simultaneously, creating a vast landscape of possibilities. Let's dig deeper into the potential of quantum computers. Picture the most complex mathematical problems, or simulations of molecular interactions for drug discovery, or even predictions about global climate changes. These tasks, which could take classical computers millions of years to complete, could potentially be solved by quantum computers in mere seconds. A case in point is Google's quantum supremacy experiment in 2019. Google's 54-qubit quantum computer, Sycamore, accomplished a task in just 200 seconds, a task that the world's fastest classical supercomputer would take approximately 10,000 years to complete. That's like comparing the speed of a snail to the speed of light. But it's not just about speed. Quantum computers can help us discover new ways of doing things. For instance, they can help us develop new materials and medicines by accurately simulating their behavior at a molecular level, a feat impossible for classical computers. They could revolutionize industries like cryptography, making our online transactions more secure than ever before. They could even find new, more efficient solutions to logistical challenges, such as optimizing delivery routes or supply chains. So, what can a quantum computer really do? The better question might be, what can it do? We're only scratching the surface of its potential. Quantum machine learning, a new paradigm in AI. Imagine you're a musician, and you've been gifted a brand new instrument, one that's so unique, it could potentially revolutionize music. But there's a catch. You need to learn how to play it. That's the situation we're in today with quantum computing. We have this powerful new tool, but we're still figuring out how to use it effectively. And that's where quantum machine learning, or QML, comes in. QML is like the maestro that knows exactly how to play this new instrument, producing symphonies of solutions that were previously impossible. Traditional machine learning is limited by the computational resources of classical computers, but QML leverages the superposition and entanglement of quantum mechanics to process vast amounts of information simultaneously. Let's take a trip to a city, any city. Now, imagine you're tasked with predicting the traffic flow for the next month. That's a massive amount of data and variables to consider. Classical machine learning would struggle with such a task, but QML thrives in it. It could process and analyze all the data at once, predicting traffic patterns with astonishing accuracy. But it's not just about predictions. QML can also accelerate the learning process. AIs could be trained to recognize patterns and make decisions faster than ever before. In fields like healthcare, QML could accelerate the development of personalized treatments by rapidly analyzing an individual's unique genetic makeup. Real-world applications of quantum AI. Let's dive into 5 areas where quantum AI is making its mark today. Drug discovery. Imagine finding a cure for a disease in a fraction of the time it usually takes. By accurately modeling molecular interactions, quantum AI can accelerate the discovery of new drugs. Pharmaceutical companies like Biogen are already exploring these capabilities to tackle diseases like Alzheimer's and Parkinson's. Financial services. In the world of finance, precision and speed are paramount. Quantum AI could potentially optimize trading strategies, improve fraud detection, and enhance risk management. Major banks like Barclays and JP Morgan are already exploring quantum computing to gain an edge in the financial market. Climate modeling. Quantum AI could help us navigate the climate crisis by creating highly accurate climate models. These models can help us understand the impacts of climate change and develop strategies to mitigate them. Companies like IBM are already leveraging quantum computing for environmental sustainability. Supply chain optimization. Quantum AI could optimize complex logistical challenges, from the optimal routing of delivery vehicles to the most efficient layout of a warehouse. For example, Volkswagen has used a quantum computer to optimize the routes of its electric vehicle shuttle service in real time. Cybersecurity. As online threats become more sophisticated, quantum AI offers new tools for defense. Quantum algorithms can help develop virtually unbreakable encryption, ensuring our digital world remains secure. Companies like Microsoft and Google are investing heavily in quantum computing research to shape the future of cybersecurity. Quantum AI's potential to solve previously unsolvable problems. Quantum AI is like a master key crafted to unlock doors that have remained sealed for ages. Let's peer through 3 such doors into problems that classical computing has struggled to solve, but quantum AI might conquer. 1. Protein folding. Understanding how proteins, the building blocks of life, fold into 3-dimensional shapes is a problem of monumental complexity. Misfolded proteins are linked to diseases like Alzheimer's and Parkinson's. A classical computer would require more time than the age of the universe to simulate these folding pathways accurately. However, a quantum computer, with its ability to handle vast amounts of data simultaneously, could potentially unravel the mystery of protein folding, paving the way for novel treatments and cures. 2. Optimization problems. Consider the famous traveling salesman problem, where the task is to find the shortest route that visits a set of cities and returns to the starting point. As the number of cities increases, the problem becomes exponentially harder for classical computers. Quantum AI, with its capacity for parallel processing, could find the optimal solution in a fraction of the time, revolutionizing fields like logistics, supply chain management, and even space exploration. 3. Prime factorization. Breaking down large numbers into their prime factors is a task that's easy for humans when the numbers are small, but virtually impossible for even the fastest classical computers when the numbers get large. This is the basis of RSA encryption, which secures our online communications. A sufficiently powerful quantum computer running Shor's algorithm, however, could factorize these large numbers efficiently, shaking the very foundations of modern cryptography. These are just a few examples of the previously unsolvable problems that quantum AI could conquer. Quantum AI holds the potential to not only solve these problems, but also to uncover new questions, new mysteries, and new horizons of understanding. The future of quantum AI utopia, or dystopia. Consider this: just a few decades ago, the idea of having a personal computer at home was considered futuristic. Now, we carry computers in our pockets that are millions of times more powerful. The trajectory of technology has always been exponential, and with quantum AI, we're about to hit the steep part of the curve. What we thought might take a decade could now be realized in mere months. On the utopian side, quantum AI promises to solve problems that have baffled humanity for centuries. It could lead to breakthroughs in medicine, environmental sustainability, and even our understanding of the universe. It could make our world safer, more efficient, and more connected. However, as with any powerful tool, it also comes with risks. Quantum computers could crack current encryption methods, threatening online security. The accelerated pace of AI could outstrip our ability to understand and control it, leading to unpredictable outcomes. And there's the ever-present concern about job displacement and societal disruption. So, is the future of quantum AI a utopia or dystopia? The truth is, it's up to us. The power of quantum AI is not inherently good or bad. It's a tool, and like any tool, its impact depends on how we use it. We must navigate this brave new world with caution, harnessing the benefits while mitigating the risks. If you have made it this far, comment down below with the word 100%, so we know that you watched the entire video. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. If you enjoyed this video, don't forget to subscribe. Thanks for watching.